Welcome. My name is Geert Lombard, and as the Program Director of the Master of Civil Engineering at KU Leuven, I would like to take the opportunity to present to you in the next 10 minutes our program in Civil Engineering at KU Leuven. Now first, what is civil engineering all about? Well, it's not exaggerated if we say that civil engineers shape the world that we live in. Civil engineers do the structural design of buildings and its installations. We build roads, bridges, tunnels, but also design and maintain all kinds of water systems. We build these for the benefit of people and society, but taking into account environmental as well as economical constraints. Now, even though civil engineering is one of the oldest engineering disciplines, it doesn't mean all challenges have been overcome. On the contrary, I would say, and I've listed here on this slide a few of the challenges we are facing today, but this list is by no means complete. So let me take a few of these and explain. When it comes to the design of buildings, we need to make sure that these buildings offer a safe and healthy living environment, but at the same time we need to minimize energy consumption. When it comes to infrastructure, in Europe as well as in Northern America, we're dealing with aging infrastructure, and we need to make sure this can still be used in a safe and reliable way, but working under very tight budgetary constraints. When it comes to waterbound or coastal structures, we're dealing with the effects of climate change, so we need to foresee rising sea levels, increased levels of erosion, we need to check the effects on wave loads, and we will also dealing with the consequences of more severe rainfall events. Now, these challenges are very diverse and can of course not be captured in a civil engineering program, in a single civil engineering program. So what we're offering in our master are three different options. The first option is building engineering that integrates all technical aspects related to a building, so including the structural aspects as well as the installations and energy. A second option is structural engineering, where we deal with the structural design of buildings and infrastructure such as roads, bridges, tunnels, and we of course ensure that all these loads can be transferred and handled in a safe and efficient way. And then our third option is hydraulic engineering, where we design and manage water systems, and these can be man-built water systems as well as a natural water system. We're also dealing with the design of waterbound infrastructures such as locks and coastal protections, and of course taking into account environmental aspects as well as climate change. Now, what is the structure of our program? So it's a 2-year master program for an equivalent or a total of 120 credits. The three options that I've just presented rely upon a common core of about 30 credits, so it's 1/4 of the program. And then these option-specific courses, they cover about 40% of the program. You will see here the option of building engineering, structural engineering, and hydraulic engineering. The option of building engineering here has been struck through because this option is only offered in Dutch. So currently in our English program, we have the two options of structural engineering and hydraulic engineering. In addition to the common core courses and the option-specific courses, we also have a number of elective components, and these include the master's thesis as well as some elective courses. Now, in a nutshell, what courses are included? Here the courses of the common core are listed. I won't go over all of them, but these include soil mechanics, foundation design, numerical analysis techniques, design of concrete components, as well as resource efficiency and life cycle assessment, which are important to assess aspects of sustainability. In the option of structural engineering, we have a number of courses that of course involve the design of these structures and infrastructure, and I've highlighted here a few that would be relevant for the design of the steel bridge that you can see on the top right of the slide. So we discuss concepts of bridge and tunnel engineering in the course of infrastructure engineering. This bridge would be built in steel, so of course the design of components in steel would be relevant. The bridge would also be subjected to dynamic loads, so that's important as well. And in structural engineering practice, you will hear about some more practical aspects of the building of such a bridge. You will also see that in the option-specific courses, we have 3 projects. So in all of those projects, we deal with the design of a particular structure in a real-life setting and with an open problem formulation. And the design of such a bridge structure is actually considered in the 3rd project of structural engineering. As a second option offered in English, we have the option of hydraulic engineering. And again, I won't go over all of these courses, but let's say here for the design of these offshore wind turbines, the ones that are again put in bold or relevant. So in hydrodynamics, you will learn about wave loads, so the loads that this offshore wind turbine would be subjected to. The actual design of the structure would be considered in the course of hydraulic structures, and here again the wave and wind loads would act dynamically on the structure, so the course of dynamics of structures is relevant as well. So here in this option as well, we have 3 specific projects where we deal with the design of real-life structures, so real-life problems, and the design of such an offshore construction could be part of Project Hydraulic Engineering 3. So more examples of the projects that are in the 2 different options. So here for the project of structural engineering, in the first project we're dealing with the structural design of a tall building, and you can see a number of illustrations for that project. And as a side note, the Burj Khalifa, which is the world's tallest building at present, is built by a joint venture with a Belgian contractor, Basics. Another example of a project, and this again for the option of hydraulic engineering. What you can see here is an illustration of an energy island which could be used for the storage of wind energy. And at present, Belgium and Denmark have agreed to build such energy islands to support the transfer of wind energy from Denmark to Belgium. In your program, you will also have a master thesis that counts for 24 credits. So this is almost half of the second year of the master program. And what I'd like to stress here is that these are embedded in ongoing research at the department. So these will offer you the opportunity to run along with a research project. And I would invite you to visit our website, which is given here as well, to learn more about the ongoing research in the different sections of the department. So after you've finished our master programs, where will you end up? Well, what you can see here are the statistics of the last 10 years of our civil engineering program. And if you look at these, you will see that, let's say, more than 80% end up in the construction sector. Many of them end up working with a contractor. You can see that that is almost for 30% of the graduates the case. Many of them also go working with an engineering consultant, dredging and offshore industry. We have some of the world's largest dredging companies here in Belgium, but also education and research is an important endpoint for our graduates. You can also see that some end up with government and infrastructure. Government is, of course, an important asset manager or infrastructure manager, and so is it also in high need of civil engineers. You will also see that not all end up in the construction sector. So of those, many end up in the insurance or banking companies. At present, there is a very high demand for civil engineers, so it's very likely that you will find a job easily when looking for a job as a civil engineer in Belgium. Civil engineering is also an important sector in Belgium. You can see here that it's about 6% of the gross domestic product, and in terms of job employment, it stands for 77.5% of the jobs. You'll also learn that there are about 8 vacancies for every civil engineer looking for a job, so you have a good chance of finding a job which really suits your interests. So then, why should you study civil engineering and travel to Leuven for our master program? Well, KU Leuven is one of Europe's, or is actually the most innovative university in Europe. Leuven is also a very nice city and very easy to live, so that's also very attractive. I would also say that with the Department of Civil Engineering, we have a very good to excellent academic reputation, so I think that is important as well when choosing a master program. And I didn't really stress, but if you go back to the slides, you will see that many of the courses are taught by guest lecturers from industry, and in this way I believe that we have a very good balance between theory and practice. We can also offer two profiles which are well aligned with the needs in industry, so given by the option in structural engineering and the option of hydraulic engineering. And as mentioned, there is a high demand for civil engineers in Belgium, and you will find that it's a very diverse sector in Belgium where we have a mix of, let's say, world players, very big companies, but also small and medium enterprises. Lastly, I would invite you to have a more detailed look at our program on the website, which is given here. I would also like to invite you to learn more about the department at our webpage. And if you'd like to have more information, please do not hesitate to contact me by email. So with this, I hope to have given you a bit more of information about our program. Please do not hesitate to get in touch, and we look forward to welcome you to Leuven for our master program.